All right, so we're going to talk about the physical properties of alcohols, ethers, and epoxides. So we're talking about physical properties, we're talking about boiling point, melting point, solubility, those types of things. And that is often, or it's determined by their intermolecular forces. So first of all, pause the video and write up the 3 types of intermolecular forces that you know about. All right, you did that. The first type is just van der Waals forces. The second type is dipole-dipole forces. And the third type is H bonding. And they are in order of weakest to strongest. So van der Waals is the weakest type of intermolecular force. H bonding is the strongest type of intermolecular force. So alcohols, something like this. Ethers, something like this. Epoxides, something like this. What types of forces are they going to have? 1 through 3. So you pause the video. You already put in what you believe they have for intermolecular forces. And now you're back. Alcohols have 1 through 3, so they have all the types of intermolecular forces. Ethers have 1 to 2, and epoxides also have 1 to 2. These are polar molecules. They're going to have dipole-dipole, but they don't have any H bonding. They don't have any OH, NH, or FH bonds, so that makes them so they can't hydrogen bond with themselves. If this ether was mixed with this alcohol, the alcohol could donate that hydrogen bond, and the ether or the epoxide could accept it because the oxygen can still make a OH hydrogen bond. But if it was just a bunch of these by themselves or a bunch of these by themselves, they're only using dipole-dipole forces or van der Waals forces. That being said, how do those intermolecular forces relate to boiling point? Here we have 3 molecules. They have roughly the same molecular weights. In your course packet, it actually says that the molecular weights are 58 atomic mass units, 60, and 60 atomic mass units. So really similar in weight. So the size, which relates to the van der Waals forces, shouldn't have any impact. Which of these 3 has the highest boiling point? All right, you already figured that out. You checked it out. Yep, so the more intermolecular forces you have, the higher boiling point you have. So this has the highest boiling point. It's actually 97 degrees Celsius because alcohols can do all those intermolecular force types. Butane is a fuel source. It is a gas at room temperature. Its boiling point is 0 degrees Celsius. So at room temp, which is about 23 degrees Celsius, this is going to be in the gas phase. Same with this ether. This ether, with the dipole-dipole forces, it has a little bit more intermolecular forces than butane, but it actually has a boiling point of 11 degrees Celsius. So you can see that the dipole-dipole forces have some impact, but compared to H bonding, it's very minimal. So that's how that works out. We're going to look at a few more in a minute. All right, so which of these is going to have the highest boiling point? This is going to be a little more challenging. Why? Because all of them have the same functional groups. All of them have the same molecular weight as well. So same molecular weight, same functional groups, same types of intermolecular forces. So which one is going to have the highest boiling point? All right, so you did your best. And what's the strongest intermolecular force? It's H bonding. And H bonding means that essentially another one of the same thing would have to be close enough and they would make these hydrogen bonds together like that, where the oxygen is using a lone pair to make a partial bond to that hydrogen. That oxygen is doing the same to that hydrogen. And the situation is that this has the highest boiling point, this one over here. So that boiling point is 118 degrees Celsius. This one in the middle is 98 degrees Celsius. And the one on the right is 83 degrees Celsius. So there's differences in their boiling points, but it's not enormous. It's not like that ether versus the alcohol that we looked at a second ago. But essentially, what's the difference between that and that? Well, when we have the alkane changes going off in one direction, that leaves the kind of business end of the molecule, the alcohol, on a lot of space to make that hydrogen bond, versus this OH is surrounded by all these big methyl groups, and that essentially crowds that OH. It makes it harder for other molecules like this to come in and make those same types of intermolecular forces, those same types of hydrogen bonds, because it's just blocked by all those alkyl groups. So alkyl groups branched, so branched alkyl groups, if this was 10 carbons long, it wouldn't really have a big impact on the H bonding ability, but branched alkyl groups like this make it more challenging, so more difficult, to H bond. So the alcohol that is best at H bonding will have the highest boiling point, melting point, etc. So yeah, that's how intermolecular forces work out.